give you an overview of what a project is, what project management involves, and then a bit about how to set up a project. I'll talk a little bit about the different methodologies, but not a huge amount, because there's whole qualifications in all the different methodologies. And if you're interested in doing them, I suggest you get a bit more information on the qualifications yourself. And there should be plenty of time for questions at the end. So the first thing we need to decide is what a project is. And a project is what we define a project is. A project is a project because we say, but in terms of project management, there's some criteria that we have to fulfill. And one is that a project is temporary. It has a time limit. And that in that time limit, you are aiming to create a product or outcome that we have defined in a scope. It's important that each project is unique and it is not just business as usual. So on the slide is the definition from the Project Management Institute. But the idea is that we want to create something, for example, in the bottom corner, I've got a box. So we want to create a box. We define how we're going to do that, how much time it's going to take, what quality the box needs to be, what size the box needs to be. We make the box and then we close the project and we have that product, the outcome.
Sorry, Josie, do you want to share your slides? I can't see them.
Oh, they're not being shared?
I can see you, but not the slides.
Can everyone see now?
It's just started. Yeah, I can see it now. Sorry,
everybody. I thought I'd shared them before we started. Thanks, Corinne. That could have been embarrassing. I've got through the whole thing without the slides. Anyway, on the slide now is the definition of a project from the Project Management Institute. So it's a temporary endeavour with a defined scope and resources, and that each project is unique and designed to accomplish a goal. So therefore, project management is the application of knowledge and skills to achieve the goals of a project. And in traditional project management, that's all it is the management of a project and not the doing of a project. So you are just there to tell people what they need to do to achieve the project, check they're doing it, and check the progress. So the role of a project manager is managing up. So you might be managing your stakeholders, you might be managing your supervisors, your bosses. It's managing out across projects, managing back, so looking at past projects, looking at progress to date. It's managing the future progress, training, strategy and direction. It's managing across teams, across collaborations. It's managing inwards, so you're managing resource on the project, you're managing your deliverables, you're managing yourself, and you're managing the people in that project team. But you might also be managing subordinates, project coordinators, students, masters, students. You could be involved in managing labs, so technicians. You might be dealing with contractors or contracts. So there's lots of different levels of management in a project. And as I've said, for research, a project management role is often making sure everything happens, and that could be doing the things as well as managing them. I'd just like to raise this point that we said that projects have a defined scope. And when you set the scope, you define what you're going to do and what you're not going to do. You define the quality to which you're going to do it and how much time and resource you need to do that. If you try and make everything perfect, you're going to make your scope bigger, which either means you need more resource, you need to lower the quality, or you need more time to do it. So in terms of project management, good enough is good enough. You need to do what you said and not more to achieve the goals of the project. And if you try and make everything completely perfect, you'll end up not actually succeeding at your projects because you'll never finish them. So if you think about a project as a shape, a set size with quality, resource and time on the axis, and the scope is whatever's then in the middle. If you have to reduce the time, you either need more resource to do everything faster, or you'd have to reduce the quality. And the same, if you increase the scope, you're going to need more time, resource, and possibly higher quality. So it's very important that you define what you're doing, and that's what you do. Don't do more, you don't do less. Project life cycles. So every project has a start and an end in some way. Traditionally, so up at the top here, we have sort of a very traditional linear view of project management, where we have an idea, we select our project, we initiate the project, and in project management, initiation means starting to plan. It doesn't mean starting to do. So you initiate the project by planning it all out. You would define your scope. You would then plan all the project and the work and everything that needs to be done. You schedule it, and then as a project manager, you monitor and control. You're not doing the project. And then you have a completion and close out, and hopefully you have your outcomes and deliverables at the end of that if it's a successful project. Now in research, a project might be a grant proposal. So you would have to find your funding, develop your proposal, submit it, hopefully get the money. You then set up the project, hire the people for the project, you manage it, you check against your deliverables, you write your papers, you close the project, and then you look for more funding. But there are other models of project management, for example, Agile, which was defined by software development, where you want to make lots of little changes and check how they work. If they don't work, you want to stop them quickly and do something else. So it's a very cyclical process of you set your requirements, you design them, you develop them, you test them, you deploy them, review them, and then start again. And so you're constantly going through these cycles in Agile project management. Doesn't really matter what model you use, most of them can be used for different projects, but it's very important that you include all the stages. So the first stage, sorry, I've skipped from my slides. I'm going to sort of research projects. Most research projects start with a question. What happens if we do this? Or what does this mean? What do I want to do? How can I do this? How can I solve this problem? You then select your funding source, you check in the literature, you write your proposal, and then have to fulfill all your sponsor requirements. So this cycle is from the Washington University, and they have lots of researches on lots of resources on research project management. So it then goes into sort of the setup of the project. So this would be getting the funding, setting up your collaborations, hiring your people, deciding on your methods, and then you go into managing it, where you would collect your data, report your data, check you're compliant with funder requirements. There's a financial section in all of these because budget is very important. There might be changes to the award, there might be sub-awards. Certainly in the Catalysis Hub, we give out projects, so we need to manage those projects as well as the main award at all times. And then the last section, which is equally important, it's a quarter of the cycle, is the closeout. So this is dissemination of your results, sharing your data, working out how you can store your records, what you're going to do with any equipment that's been bought. And it shows this as a cycle, so you go from beginning to end, but often in research you'd have multiple projects, so these would be overlapping cycles rather than one after another. The first step in a project is defining it, and I've put up this little cartoon just to show the importance of both defining a project and making sure everyone understands what that says. So this is just a little cartoon on the engineering of a swing to show how it can go wrong and how people can misunderstand. I won't go through all the stages because you can probably see them, but it's very important not only define your project, but to get everyone involved to agree what's in the project and what's out of the project. And so at the end, everyone is happy with what is produced. So it might not be a swing you're producing, it might be a paper, it might be your thesis, it might be a beam time, you could be building the next Rosalind Franklin Institute, but everyone needs to know what it should look like at the end to know whether you're successful or not, and to know how to get there. Otherwise, you're going to get to the end of the project, and even if you think it's a success, it might not be deemed a success, and that could be detrimental to future projects. So it's very important to sort of communicate what you're doing in your project, what you're not doing in the project, and make sure everyone understands that and agrees on it. So if you're defining a project, you need to clarify your scope. So clarify who's going to do what, how it's going to be done, what the benefits are, what the products are. You need to understand if you're writing a research project, what the funders' requirements are. So a lot of projects have a midterm review, and if you're not achieving what you've said you're going to achieve, they can take the funding away, which would be a project failure. You need to get involvement and support. So if you're applying for Beam Time, you need to get support from the Beamwise scientists. If you're applying for a research project, you need to get support from the university so that they're happy for you to host that project. And you need to get agreement and sign off on what is the scope and what isn't. So to initiate the project, you have to plan it. And that is partly the scope, but you need to sort of define the outputs, the activities, and what it's going to depend on. Is there going to be a shutdown of the synchrotron, which means you won't be able to get any beam time, or you need to apply for travel money to go to America to get beam time there? You need to define who's going to do what. So are you going to have a master's student? Who's going to fund that master's student? You need to estimate everything involved, so the time, the people, the money, the equipment. You need to manage your risks and control changes. So we need to identify what we're going to produce, and those products should create outcomes, things that change as a result of that product. Are you going to discover the next sustainable aviation fuel, and what outcomes would that produce? And what benefits will those outcomes cause? So this could be part of your statement of impact if you're writing a grant, what the product's outcomes and benefits are for society, for economy. You need to schedule your project. You need to have milestones, activities, tasks. Most people have some sort of scheduling chart, Gantt chart with your milestones on it. You need to have some sort of risk mitigation plan. So you need to identify your risks and decide how you're going to deal with them. And once you've got all this, you should have some sort of baseline plan. I'm going to go into some of these aspects in more detail, but this is all before you start the project. This is what you need to have. This could be a formal document. If you're working in a company, they might have a template for a project that you have to follow. It could be scribbled down on a piece of paper if it's a Friday afternoon experiment that you're doing and you just want to test a quick hypothesis. You've got 2 hours. You don't then need to do all these steps explicitly, but you will do them mentally in many cases. So to identify the products, you need to decide what the project is going to produce to satisfy the aims of the project. So for a research project, this could be papers, patents, samples, it could be software, it could be a new process, it could be a new catalyst. We also need to know who's going to use the product. There's no point in producing 300 research papers if it's industry that's wanting to use what you're doing. They would probably be more interested in some sort of IP. You need to know what information is needed for the product. Does it need a software manual? Does it need background information? You need to know the quality. We've all seen papers that probably aren't up to the quality required, and we've all seen very good papers. So you need to know what quality will satisfy the project and have some sort of tolerance on that. And then you need to know what activities you're going to have to do to produce that product, to review it and to accept it, to say that's it, it's done. You need to identify the stakeholders. It's very important in a project that you have people who support the project, but a stakeholder is anybody who can be affected negatively or positively by your project. And there's a little table here that has some ideas of where you might find stakeholders. It could be your funders, it could be a PI, it could be a collaborator, a colleague, but you want to have some idea, and a lot of people just brainstorm this, about who's going to be affected by the project, who has influence over the project, and who has an interest in the project. And then you need to decide who has power, who has interest, and who may not care. And then manage those stakeholders according to that. So there's a grid at the bottom of the screen that has power and interest as the axes. So if someone has low power over the project and low interest, you just need to monitor them, give them the occasional communication. However, if they have high power over the project, for example, a funder who could pull funding and are very interested because it's a strategic project, you need to manage them closely, communicate often, and keep them satisfied. Which comes to the next important thing in project management, which is your communication plan. So in a project, there's a whole load of people that you need to keep informed, and you need to decide how you're going to tell them and when. So you're going to send out a weekly email to everybody involved in the project, giving them an update. I think I've got timings on this, it keeps jumping forward. Are you going to have a monthly meeting with someone, one-to-one, or on Zoom? Are you going to have social media posts? Is there going to be a newsletter? It's very important that everybody who needs to know is kept in touch and that you communicate. It's a major failing of some projects is when the communication plan is poor. Once we've got the structure of the project and what we're going to do, we need to decide how much resource that project is. Now, we need to decide the time, the resource. That could be money, it could be people. Turn the timings off. And we normally do this by breaking down the tasks in some way and then estimating how much time is required. And we normally put a tolerance on that. If we are overly optimistic, and people generally are, in what can be done in the time, you may find you don't have enough time to complete your project. So it's normally said that you need to give a 20% leeway for people being optimistic about what they can do on a project. So when you're estimating the time, you need to give yourself a tolerance to allow for sickness, people going on holiday, people having to be taken off to do other tasks, all sorts of things, just to give you leeway in case something goes wrong or something goes right. There are a number of ways of estimating your time and your resource, but a lot of it comes down to practice and experience. The more you do it, the better you'll get. And often the estimate will vary depending on the stage of the project. At the beginning of the project, you may say, I think this is going to take about 2 years and it's going to need about a postdoc and a half. And then as you plan the project further and further and break down the work that you're going to do, you will refine that estimate and make it more accurate. But there are a number of ways people do that, and I'm just going to give an overview of some of those methods. If you're interested in any of these methods, I suggest you Google them or find a textbook. Bottom up is probably the easiest to explain, in the fact that we take the project and we break it down to every task we're going to do. We estimate what we need for that task, and then we add it all up at the end. So it would look something like this. So this is for an IT project, but it just gives a breakdown of all the work, how much resource I need, how long it's going to take, and what it's going to cost. And then I add it all up and I say that's what I'm going to need for the project. Obviously, this is quite time consuming, but it's probably the most accurate measure. The other side of the scale is the top-down estimation, where I look at the project as a whole and I estimate from my knowledge and historical projects what I think it will take. It tends to be much greater error in top-down estimation, but it'll give you an overview, and often these two methods are used together. Similarly, we have comparative methods where we look for a project that's been similar. So if somebody else has had a beam time in the past, or a project, or someone's built a building that's very similar to the one we want to build, or bought a bit of kit, we can look at that and say, well, they needed this. My project's slightly different, so I might need this, but this is the estimate of what I need. The other two models here, the parametric and the 3-point, involve building a mathematical model of your project. So for the parametric measure, I effectively model what one task will be. I say what the relationship between one task and all the rest of the tasks are going to be, and then I multiply. So this could be something like, if I'm building a motorway, I know how long 1 mile of motorway is going to be, and I need to do 50. So I'm going to multiply the estimate of one task by 50. However, if it was something like writing a thesis and I knew what one chapter would take and how much resource was needed by that, I might have to put a model in place, because as I write more and more chapters, I'm going to get more and more bored. So they might take slightly longer. But also I might get slightly better at it. So I might be slightly faster. So there would be then a mathematical model to predict how the estimate for the one task related to the whole project. So building the models is time consuming, but if you get the right model, it should give you a good estimate of what the project is going to need and how long it's going to take. In terms of 3-point estimating, it's similar, but for each task and for the model, I choose the most likely case, but I also have an optimistic and a pessimistic estimate. So I have that buffer of if everything goes wrong, and in the worst case scenario, this is how long it's going to take. And then if everything goes right, and I get the most experienced postdoc to run the project, and all my chemicals arrive on time and no bits of kit break, then the project will take this long. So I have those 3 points, and again, there's a model to model that onto the project. And with the 3-point estimate, you can use sort of a critical path analysis, or what some people call PERT, which is Program Evaluation and Review Technique, which comes from the US Navy, which is designed to create critical paths and then look at a pessimistic, optimistic, and most likely evaluation for each task and give you the minimum time for the project based on that critical path analysis. All these models have pluses and minuses. So if we're looking at the top-down model, it uses historical data, which is probably quite accurate. But it's just we think about this. The bottom up, on the other hand, takes a long time. It takes a lot of effort to create, but it's very accurate. And then we have the 3-point and the parametric in the middle, where depending on the models you use will depend on the accuracy, and they can all be coupled. In reality, we might do a mix, or it depends what we've used in the past. Don't get too bogged down. Everything's only an estimate. And I'd say the best piece of advice on this slide is to talk to the experts. Find somebody who's done it before. Go and talk to, if you're planning a grant, go and talk to your research and innovation, your pre-award team. They've costed lots of grants. They can help. Or talk to someone who's costed a similar grant, or someone you know who's done lots of grants. Use historical data to look at what other people have done. If someone can give you something they've already done for you, you don't have to reinvent the wheel, and then you can just alter it to fit your specific situations. But do understand what your project needs, and if you're not sure, talk to somebody who does. You don't want to miss things out. You can use different methods together. And as they say here, this is actually an advert for the program evaluation review technique. So that's why they've got it at the bottom, but it is a useful method if you want to look into that, for looking at things like critical path analysis and working out what the realistic order of doing things and what that's going to mean for the time of your project is. I'm not going to go into too much detail on people and teams because it really will depend on what you're doing. We'll need a completely different team structure and hierarchy and skill set if you're creating a building compared to if you are running a beam time. But the team will depend on the culture of the organisation you're working in, who you're working with, what their priorities are, what the agendas are of the people you're working with. It's not always the same as your agenda. What sort of contracts you need to have in place, who the partners are, is it industry or academia, what the IP arrangements are. Are you working on your own? Are you managing people? Are you working with collaborators? So this all needs to be defined, but will depend on the project that you're doing. And hopefully there's enough similarity in the projects that you're doing that you can find someone who can help you set your team structure. So again, it's a case of if you don't know what you need, talk to someone who does or can help you define that. Change control is very important in project management. In terms of the projects I've managed and the projects I've worked with, I'd say scope creep is one of the biggest causes of failure. And scope creep is when you have a defined scope and then people go, oh, can you just do this? Can you just try this? What would happen if? And you end up going down all sorts of little rabbit holes, doing all sorts of side projects, adding all sorts of features, and you never get to the end of your project because it keeps growing and growing and growing. So when you set up your project, you need to define how you're going to manage this. And there's generally two answers. Yes, we can do this, but it's going to affect the time I need, the resource I need, the quality that you get, or no, because it's not going to benefit the project, it's not relevant, or it's not in the scope. And there is a process in most project management methodologies for managing change, and it's called the change control process. It is that when you receive a request for change, you clarify. So you ask the person exactly what they want to do and document it, which could be an email or it could be a formal document template. You then look at that request and see what it's going to do to the project. Is it worth it? Is it going to have a positive or negative effect on your outcomes? You then decide what you're going to do and you notify the person that's asked you, whether it's a yes or a no. You then document what you're going to do. And if the answer is no, we can't do that, that's as far as it goes. If you are making a change, you need to adjust your project plan. So re-baseline your project and then manage the rest of the project to that new baseline that you've now created due to the change. So this means that any change becomes part of the project and is documented and agreed by everybody so that everybody knows what's going on. And it's not just a case of the goalposts keep changing and you never reach them. The other thing you need to change, control in the planning process is your risks. Now, I think most of the people who had registered were scientists or work with scientists. And so we're probably very aware of the process of managing risks. We all write risk assessments for our experiments. And for a project, it's no different. You're effectively doing a risk assessment for the project. You are looking at what can harm the project, what hazards there are to the project, what that impact might be, how severe and how likely. Risks generally arise either from the doing of the project or the product that you are creating. So if the risk arises from the implementation, the project may not proceed to plan. If the risk arises from the project might fail because you don't produce the project, you don't produce the product that you agreed at the beginning in the scope. So we need to identify all the possible things that could harm the project, all the hazards that could have an impact. I mean, obviously, we don't know the future some aren't knowable. I don't think anyone probably 18 months, 2 years ago put pandemic in their risk assessments of projects, but I can probably guarantee that it's going in now. But we need to decide for every risk how we're going to deal with it. So we could set up a contingency plan. So we could say, what do we do if this happens? So we have a plan B. So if there is a pandemic, we all start working from home. We can avoid the risk, so just get rid of it. We could change what we're doing so that's no longer a problem. For example, substituting a less dangerous chemical for one that's very hazardous. We can transfer our risk, so we could set up a contract or some sort of insurance against it. So if we were planning an event as part of our project or as the project, we could have a cancellation insurance in case we have to cancel it. We can try and reduce the risk either by reducing the probability that it happens or the impact if it does happen. Or we can just accept the risk. If there is nothing we can do, we accept it, but we monitor it. We keep an eye on it. We keep looking at the impact of the probability at all stages of the project so we can manage the impact of that risk. So most projects will have some sort of risk register where we list all the risks. We have an assessment of how likely they are and what the impact of the project is, and also when they might happen in the project. And then what we're going to do about them and who owns them. Is it something that you are looking after as the project manager, or is it something that the person doing the research needs to do, or the person fulfilling the project, or is it something you need to escalate to the funder or the university? And then this risk register is in the plan and everybody agrees it and knows who has responsibility for what. So everything so far is then part of our baseline plan. So we have our deliverables, our milestones, our goals. We have a communication plan. We know who our stakeholders are. We know who's going to do what and what the roles and responsibilities are. We know what our resources are. And we had it all written, documented, and set up and agreed. And this gives us, everybody on the project, a common point to work from and captures the entire planning of the project and gives us a baseline that we can then change if we have change requests, or that we can go back to measure our project. And the important thing is that it's all documented, agreed and communicated so everybody knows what's in the project and what's not. And once we have all this, we can then execute the project and monitor and control it. So to start the project, we need to, as a project manager, traditionally, your role is to delegate and assign tasks, not to do them. But in research, you might find that you're also doing the doing, in which case you need to make sure that you make the time to manage the project as well and not just forge ahead and don't stick to your scope. So you need to be constantly monitoring your progress, correcting problems, seeking advice, escalating problems if they're going above you, if it's something university needs to be involved in, and keeping everybody involved, all your stakeholders informed. It's very important in any project to manage expectations. The sooner you can tell people about problems and issues and give them solutions, the happier they're going to be, even if that problem derails the project. If you have a problem and don't tell anyone about it for 6 months, they're going to be quite annoyed. Whereas if you tell them about it and give them a solution or tell them what you're going to do about it, they tend to be much more accepting. We are constantly, as a project manager, looking at where we are and what we're doing now. Are we where we plan to be? Are we going in the right direction? And how do we get back on track? And we're generally judging this about against resource, so against time and money, and against the milestones we defined in the project plan. And then we estimate where we're going to get to in the future and if we're still on track to achieve the rest of the milestones in the project. And this is a constant cycle. So we are constantly looking at what's been achieved, the progress, and estimating comparable to the plan where we're going. We need to look at where things aren't where they're meant to be, and hopefully in our estimates and our resources and our quality, we have tolerances. So if there's small discrepancies, this is within the tolerance and we can solve them. If the discrepancies aren't within tolerance, if there's a major problem, we need to escalate them to the funding body, to the university, to the PI, and replan the project under change control to achieve whatever we still can. So I imagine there was a lot of projects as of sort of the end of lockdown, the reopening of labs, that had a slight change and refocusing due to the delay that lockdown caused last year and going on into this year. So there was a change in scope due to that. So we need to constantly be on top of that so that we understand what can be achieved and where we're going. And if we do all this, in theory, we should have successful projects. So we need to sort of do all the things that I've mentioned. So we need to define our vision and goal. We need to work with the funders, the team sponsors, the stakeholders. We need to choose the right team for the project and choose a good project manager. We need to create a project plan and milestones to achievements. We need to set up our meeting schedules or communication plans. We need to manage the process, constantly correcting where we're going. And if we do all that, it should all contribute to a successful project. And once we've achieved the project, we need to complete it and close it. Now, closing a project is often the forgotten step. People get to the end and kind of go, well, I've done, walk off. But we actually need to have a formal closure procedure so that we know what went well and what didn't, so we can learn lessons from the project and the management of the project, so that we don't repeat them, or we do better next time. If there's any lessons, any training that needs to be done, we need to feed all this back to the stakeholders, to sponsors. We need to disseminate our results. We need to hand over any products, whether that's a new process, a new technique, a paper, a patent. It all needs to be handed over. It doesn't stay within the project forever. We might need to publicise our project, and we need to disband the team, especially if it was a sort of project within an organisation where the team has come in from all over outside their day jobs to do aspects of the project. And then the most important thing, obviously, is to celebrate the end of our project and then move on to the next step, the next project, whatever that might be. So in theory, that is project management. There are lots of defined methodologies that cover all these aspects in slightly different ways, and I'm just going to give you a quick overview of some of these methodologies. I'm not really going to go into any detail on the methodologies themselves, other than to tell you what some of them are, because they are entire webinars, courses, qualifications in and of themselves. But after here we have the waterfall project methodology, which is the very traditional method where we set our requirements, we design our project, we develop our products, we test them, we deploy them, and then we maintain our products, and that's the project done. We would have a breakdown of our tasks and our products, our deliverables, and we would just work methodically to achieve them. Agile is almost the opposite of that. So Agile, as I said earlier, came from software development. So it's a fail fast and try again methodology where communication and feedback is very important. And we have sort of an inception, design, construction, transition where you implement and then you think of a new idea, you design it, you create it, and you transition to using it over and over again in very quick, repeated cycles. PMBOK is the project management body of knowledge, and this is very popular in the US. And it has 5 processes in a project, which is initiating, planning, executing, controlling, and closing. But within those 5 processes, there's 10 areas for the project manager to manage, which are communications, cost, human resources, integration, procurement, quality, risk, scope, stakeholders, and time. So every project has these 5 steps and 10 things that you need to manage to achieve the project. PRISM is slightly different because it's a methodology that requires accreditation. So you can't use it unless you're accredited. And it's projects integrating sustainable methods. And it has 5 areas to manage, which are people, planet, profit, process, and product. So it's the only one really to include an environmental aspect to a project. And it's generally used in sort of large construction style projects. Prince 2 is the most common in the UK, and it's projects in confined environments. And it says it's tailorable to any level of project and any other project methodology. So you could, for example, combine Prince 2 and Agile. And it has 5 stages. So you start and initiate your project, you plan and direct your project. You then have stages of your project that you manage sequentially. So you would plan stage 1, you would execute stage 1, you would close stage 1, plan stage 2, execute stage 2, and then you close the entire project. And it has very defined roles and responsibilities within that methodology. The critical chain uses something like the project evaluation review technique to decide on the critical path of projects, which tasks are completely critical and which are secondary, and it allocates the resources as quickly as possible to those critical tasks while ensuring there are resources available for the other tasks involved. So you're looking at what tasks are dependent on what resources and assigning them appropriately. Within these projects, there's a number of tools that you can use. Microsoft Project's probably the most famous, but there are a whole range of tools, some of which have free accounts. So Asana is one that we use, so you can set up project teams, you can assign roles and responsibilities, you can assign tasks to people. There's free accounts on it, as is with Monday. I've not used Monday personally, but I know it's a popular one. With any, you need to suit the tool to a level. If you're building the next RFI, I doubt you're going to be able to do it with just the free account on Asana. You might need something with a bit more complexity. But nearly all projects will have some sort of progress chart. A Gantt chart is probably the most common. It didn't used to have dependencies when it was first developed, but this is a sort of a Gantt chart where you have your tasks down here, you have your time across the top, and you have sort of dependencies and sequence across the axes. And it was probably most famously used on the Hoover Dam. A Gantt chart was one of the first uses. Logic charts and PERT charts show dependencies and critical paths, and will often have a estimate on tasks of the fastest and the slowest, and what tolerance you have in terms of time and resource for tasks to get them done in the minimum amount of time. Product breakdown and work breakdown are very similar in the fact that you take either the products or the tasks that you need to do, and you break them down into subtasks, and then the tasks under that, or products and the subproducts under that, to create the final deliverables of a project. And then we come to the sad part, which is when projects go wrong, and they do. Not every project succeeds, not every project goes to completion. And part of the role of the project manager might be to end a project, because there is no point in throwing more money and more resource at something that's not going to achieve what it set out to do. Now, failure could be the project manager's fault, but it isn't always, and often isn't at all to do with project management. Sometimes it might just be a change in the organisation's priorities and they no longer want that project to run, in which case you have to close it out. And Kiss Flow, who created this chart, says that's about 40% of the time for traditional project management roles is why a project fails, is because the organisation changes its mind and doesn't want to do that anymore. But other reasons could be lack of planning. So if you've not planned your project, it's not clear what your goals and objectives are. How can you get somewhere if you don't know where you're going? Lack of project visibility, especially in sort of corporate project management where people are competing for resources to achieve projects. But we're all competing for funding. If we're going for funding, we're not all competing, but funding is a limited resource. So if we're not visible in what we're doing, we might not get the resource we need. If we don't communicate effectively, if we don't communicate what we're doing, what needs doing, what's going wrong, projects might fail. Scope creep is a very common, as I mentioned earlier. So the constant expansion of the scope, which makes then the whole project unachievable. And also unrealistic expectations, either being overly optimistic or just not being realistic in what can be achieved. And it may be that we have to terminate projects early. In research, it could be because everything's worked, all the kits worked, nothing's broken. The researchers were really effective and we've actually completed everything ahead of schedule, in which case it's a great reason to terminate the project early. But technically it could not work. Somebody else could publish the results and there's no point in continuing. A PI could quit, move on, retire, leaving the project without a sponsor. If the project's not really achieving, some have a midterm review and funding can be pulled at that point, or funding could be pulled for other reasons, including political. There could just be a constant barrage of things going wrong. Equipment could fail. If you need synchrotron access, it may be that the synchrotron shuts down or breaks. Or you might just not be able to achieve the desired objectives, in which case you may have to take the very hard decision to stop using the resource that you have for that project, because no matter how much resource you throw at it, you might not achieve what you set out to do. That's all I had to say. Are there any questions? There's some in the chat.
If you just want to pop your questions in the Q&A. Okay, there's a question now. Just a question about how to deal with the conflict between different parties whilst managing the whole project. Do you have any suggestions, tips on how to deal with that, please?
This is always the question I ask people in an interview. How do you deal with conflict? And the answers that I'm looking for are generally the best way to deal with conflict is communication. And conflict often occurs because you're not managing expectations. So if somebody thinks you're going to work 24 hours a day and you only want to work 7 hours a day, that's going to create conflict. So you need to be very clear in what can and can't be done, and where the project's going, and make sure everyone agrees that beforehand. If it's a collaboration that's involved in the project, again, it's setting out responsibilities, roles, who's going to do what, when are they going to do them by, and if there's a problem, communicating it early, and if possible, giving a solution so everyone knows. what's going on, and there's no sort of surprises or people thinking they're doing, or you're doing something different to what you are. I hope that answers that question.
Okay, someone's asking, you mentioned that as a PM you need to manage up, and they found that very hard to do. Do you have any tips?
Yes, depending on the people you are managing up, this could either be an easy task or a very difficult task. In terms of managing up, it's about, again, to a certain extent, managing expectations. What does that person want from you and from the project? So do they want to know every day what you've done? So do you need to type up a little report at the end of the day to give them a progress update? Do they just want to know when you've succeeded? In which case you just need to let them know when the milestones have been achieved. And then if something goes wrong, they need to know. Or if something's not going as planned, it doesn't necessarily have to be wrong, but if something's been discovered or something's just diverted slightly. And setting agendas is very important, I think, in managing up. So if you go into a meeting with someone, go in with a clear expectation of what that meeting is going to achieve, so they know what you're going to tell them, what's involved, and then you can control the outcome of the meeting.
Does anyone have any more questions? I don't see any. Someone's mentioned they like to see the creep concepts mentioned.
Everybody always wants extra, whether it's a sort of you're creating a product and people just want extra features, or it's a series of experiments and somebody's like, oh, well, this would be interesting, why don't you just try this? Everybody always wants something more, and you've got to decide whether that more benefits what you're doing or not, and then how it impacts, and communicate that, because people think just asking just to do this isn't going to have any other impact, and of course it does. I would just like to say, if anybody does have any further questions or would like to chat further or have any more information, please do get in contact with me. I'm happy to help where I can. But if there are no further questions, I hope that's because I explained everything well. But if you do think of anything, please do get in contact. My email's on the Catalysis Hub website, and we will put the recording up on the Catalysis Hub YouTube. We have another tutorial website on patents in June, and some scientific webinars coming up as well. So please do have a look at our webinar pages and check out what's coming up, because there's an exciting program that Corinne's created, as she's put up in the chat. But if, oh, there's one quick, oh, just a thanks. Well, thank you all for coming, and I hope it was useful, and I hope to see you all soon.
Thanks very much, Josie. Thanks everyone for coming.
Bye.